New problem, same approach. We've got radical on the left side of the equal sign and a radical on the right side. Why don't we just go ahead and square both sides? So I'll indicate it. Here's the quantity. Square root 9y plus 4 squared equals, let's square this right side, square root 8y plus 10 squared. And when we square the square root, right, we're squaring the square roots, the radicals just come off, and we get 9y plus 4 equals 8y plus 10. Now, let's subtract this 8y, and we got 9y's over here. I got more on the left than I do on the right, so I'm going to subtract these out. So 9y minus 8y is just y plus 4 equals 10. Let's subtract 4. We'll get y equals 6. Now, right now, this is just a potential solution. We need to check it. So let's write our check. I'll do it up here at the top. Let's say if y equals 6, then, all right, now, we're going to put this 6, that doesn't look like a 6, does it? That's better. We're going to put this 6 back into the original equation and see if we get a true statement or a false statement. So let's put that 6 in here. We're going to get the square root 9 times 6 plus 4 equals square root 8 times 6 plus 10. On the left side, we're going to get the square root of 54 plus 4 equals, on the right side, how about a 48 plus 10? And this gives us the square root of 58 equals square root of 58. And it's okay that we don't know the square roots of 58 because we have square root of 58 equaling the square root of 58. So 6 checks. So let's conclude now that our solution set here is 6. And yet another problem, but the same approach. What we're going to do is square both sides, right? On the left side, we have a radical. This isolated is here by itself. So let's square both sides. I'll indicate it here. Quantity, square root of x squared plus 4x minus 16, that quantity squared equals the right side squared. And on the left side, when we square the square root, that radical comes off and we're left with x squared plus 4x minus 16 equals, okay, x squared on this right side. And now we'll subtract this x squared from both sides. So if I subtract x squared from both sides, I'm just left with 4x minus 16 equals 0, from which we will get 4x equals 16, divide, x equals 4, potential solution, right? Potential. So let's check this. We'll write our check, and we will say, as we typically do, if x equals 4, then, so let's put this 4 back into the original equation and see if we get a true statement or a false statement. So this will give us the square root of 4 squared plus 4 times 4 minus 16. That's equal to 4. This will give us the square root of 16 plus 16 minus 16 is 4. Those two 16s will go out. We'll get the square root of 16 equals 4. We'll get 4 equals 4. It looks like everything checks. So we'll conclude now that our solution set here is 4. In this problem, we already have a radical that's isolated. So let's just start by squaring both sides. So we'll get the quantity. Square root 49 minus 13x, that quantity squared, equals the right side squared, x plus 7 squared. And squaring the left side, again, we're squaring the square root, so the radical comes off. We get 49 minus 13x equals, and we know how to square this right side, right? We're going to talk our way through this. We're going to square the first. Right, so I've got a first and a second. I'm going to square the first. I'm going to multiply these two together, 7x, but double it, 14x. And I'll square the last, plus 49. So we have an x squared on the right side. This is a quadratic. We know how to solve quadratics. Get everything on one side, 0 on the other. So why don't we get everything on the right side over here? Let's subtract 49, add 13x. So if we do that, we're going to get 0 equals x squared. Now, we've got 14x. If we add 13x, that'll give us 27x. Oh, and then what have we got here? We've got 49. We're going to subtract 49. That'll just give us 0. So here's where we are. 0 equals x squared plus 27x. So let's factor. We'll get 0 equals, we can take an x out of here, right? So we'll get x, and what's left? But an x plus 27. And that'll give us two solutions. 0, now that 0 is coming from here, and negative 27 coming from here. So we have two potential solutions. We need to check both of them. So let's start up here at the top. Let's say check. Let's just choose one of them. I'll choose the 0 first. If x equals 0, then, and we'll put this 0 back into the original. We don't want to put it anywhere down here because we may have made a mistake. Put it back in the original. So this will give us the square root of 49 minus 13 times 0. That's equal to 0 plus 7. And the negative 13 times 0 is 0. So what we're going to get here is square root of 49 equals 7. And sure enough, square root of 49 is 7 equals 7. Looks like 0 checks. So we've got at least one solution, 0 so far. But we also need to check that 27, that negative 27. So let's say this. If x equals negative 27, then, putting that 27 back in the original, we'll get 49 minus 13 times negative 27. All of this is equal to negative 27 plus 7. Okay, now before I even go any further, look, this is a square root. That's positive. Equals negative 27 plus 7. That's going to be negative. This just can't happen. So I know right away there's going to be no solution at negative 27. So the 0 works. The 0 is going to work just fine, but the negative 27 does not. So let's just conclude that our solution set here is 0.